here. So I'm Emily, and I'll start a little note here. I'll post these notes for you guys after class. So don't worry, if you miss something, then I'll just post them. So I'm Emily. Emily spelled funny. So many E's. Emily Lee, can you believe it? That's love. I don't know how long I'm taking over for Shaun. I know he can't talk, so that's a problem, especially in our profession. So, but I'm teaching another pre-calc section, so no worries. So what I'm going to do is you'll have these notes. So just a couple of just kind of housekeeping items. First things first, I will post these notes on Moodle after class. And the video from class is going to be, I'll just mute everyone here. I'm just so quiet, I couldn't even tell. So the video from this class is going to be available on YouTube. So the video from class, from class will be posted on YouTube. And if you search Emily Lee, you should be able to find me. I'll show you. And I don't have a fancy YouTube or anything like that. No playlists, no nothing. I just post all my videos as they come up. And so if you just search for Emily Lee, there's a way more popular, or way more famous, I should say, Emily Lee, but that's not me. And then there I am, 84 subscribers, 309 videos. There's something a little bit off there, right? But no, it's okay. So that's where you'll find the videos. Once I get the process video from Zoom, then I'm able to upload it. So sometimes it takes a little while, but. Okay, so let's see here. Oh yeah, for questions, I keep an eye on the chat. So I've got the chat right here, right here. So if you do have a question, then definitely if you don't want to turn your microphone on, that's totally fine. You can ask it in the chat, or you can cut me off with your microphone. That's totally fine too. But just remember, it's going to be in the recording. So if you don't want that, then just ask it in the chat. Okay, so let's see here. I'll change the name of this so we know where we are. Math 120, Shaun's class. More for me than for you. So it seems to me like you guys are finishing inequalities. So, well, before we get started, do you guys have any questions for me or anything like that?
Yeah.
Sure.
Well, I don't have anything, right?
Sorry, I had to turn up my volume. Sorry, I missed your question.
Not yet. That's,
oh,
I need to remember to actually speak up.
No, it's fine. It's like when you wear the mask. All of a sudden, everyone's all quiet.
Mm-hmm.
No, that's great. Okay, so section 1.8. Section 1.8 continued. Now, I understand there's been some disruption, you've had some canceled classes. When was it that you guys worked on 1.8? Like when, because I know you finished off, you didn't quite finish an example. Should I restart the example maybe?
Might be a good idea since we also missed out on Monday's class.
Oh, so it's been at least a week.
It's
Or
been
I
a
guess
week.
you guys have class on Friday, but let's just start over.
Yeah, let's yeah.
How about that? So if we have something like uh, x times x minus 2 squared times x minus 3 to the power of 3 is less than 0. Okay, so to solve this, right, to solve this, we're first going to find the zeros, right? Because if it wasn't equal to, or an inequality with respect to 0, then we would have to shift everything over first and get 0 here. Because 0 is the easiest value to work with, right? Where does it cross the x-axis? And so what values of x make this 0? And then we can go from there and say, okay, well, if we can figure out which values of x make it 0, then we can use that to figure out which values of x are going to make it less than or equal to 0, right? Which is what we want in this inequality. So to solve this, right, the first thing we're going to have to do is move all terms to one side. So the inequality is with respect to 0. Right, in this case, that's already done. Okay. Second step, we have to find all the values of x that make it equal to 0. So find all the values of x that make this equal to 0. Okay. Oh, and by now, all my students are used to my not very nice writing. So if there's anything that you are not sure what it says, then absolutely just let me know. I know it's not very good. What can you do? You'd think it would get better writing so much, but it gets worse actually. So we have to find all the values of x that make this equal to 0. So in this case, right, it's nice and factored, so it's quite easy to see which values make this 0, so we call those the zeros. X equals 0 is a 0, x equals positive 2 is a 0, and x equals positive 3 is a 0, because those values, right, if I plug in x equals 2 here, 2 minus 2 makes 0, 0 times anything makes 0, and so on and so forth. So in this case, x equals 0, 2, and 3 are zeros, right? Making this whole thing equal to 0. So what we do is we can set up a number line if we want to, or we can just kind of look at the intervals that break this up. So the values 0, 2, and 3 are going to break up our interval. So what we can do then, the third step that we're going to use is use the zeros to set up intervals. Use the zeros to set up intervals. Okay. So what that's going to look like is, okay, starting at x equals 0 here. Anything less than 0 up till 0 is going to be one interval. Between 0 and 2 is going to be an interval, and between 2 and 3 is going to be an interval, and anything larger than 3 is going to be an interval. So you can imagine a number line, if it helps, right? If we put 0, 2, 3, they don't have to be properly spaced. They can be just, we're just trying to visualize this thing, right? And so in a table, what this would look like, right, is you have x less than 0. That's for this portion here, right? And so we can do x is less than 0 for this portion. Actually, let's do this. Between 0 and 2, x is less than 0, but greater than 0 and less than 2. What a bluff. And then x is between 2 and 3. And then for this section, x is greater than 3. Okay. So we've got these intervals here, and what we need to figure out is knowing a little bit about the shape of something like this is that it's probably going to be some sort of wavy looking thing, right? And so what's going to happen is it could potentially start here and kind of go, oh, well, it wouldn't cross the x-axis there, here, maybe crosses here, goes through 2, and then 3, and then up again, right? That's a potential shape of this thing. All we know is that at 0, 2, and 3, it's equal to 0, so that's where it's equal to the x-axis here, so that's where it crosses. So in a table, we have x less than 0, x between 0 and 2. So now I'm just translating these intervals into a table because I saw Shaun likes to use the table, and it's a really clean way of doing it. So I'm going to adopt the same method. X is between 2 and 3, and then x is greater than 3. So what we want to do is, okay, so we've got these intervals, right? And you know what? Just to keep things nice and clean here, I'm just going to divvy them up so I keep them kind of so they don't overlap into each other. Okay, so then the next thing I want to do over here on the kind of in the margin of the table is I'm going to put all my factors. So my factors here, in this case, I can look at how x would behave, how x minus 2 squared would behave, and x minus 3 squared would behave. So, to the power of 3 would behave. And so I'm going to break these all up, and that's going to tell me the overall behavior if it's positive or negative. So I have all these factors, x minus 2 squared, and then x minus 3 to the power of 3. Okay. And then, well, usually it likes to straighten out the line. That's okay. And then overall, right, the combination of these, x times x minus 2 squared times x minus 3 to the power of 3, overall, right, the sign of x when x is less than 0, right, times the sign of x minus 2 squared when x is less than 0, times the sign of x minus 3 to the power of 3 when x is less than 0 is going to give us the overall sign of this whole thing, right? The sign tells us if it's greater than 0 or less than 0, right? Positive or negative. And so we use that to figure out which intervals this whole thing is less than 0, right? We're looking for where are these values negative together. Okay. So, clean this up a bit here. There. Nice. So if x is less than 0, what you can do is, if you need a little reference point, you can pick any value within each interval as a test value, right? For x less than 0, it's kind of easy to think about, but if you pick kind of a test value, let's say -2, right? Test value here might be between 0 and 2 at 1. That's a nice value to work with. Between 2 and 3, we're a little bit hooped, so I might use 2.5. There's no nice number here. Greater than 3, I'll use 4. Right? These are just to help me figure out what the sign is here. So for x, if x is -2, well, that's a negative number, right? And so what we have is we have a negative number. I can keep working across this way, or I can fill it out this way. Doesn't matter, you're gonna fill out this whole table anyways. But if x minus 2 squared, if you had -2 minus 2, that's a negative, but any square value is gonna be positive, right? So any negative number is gonna be positive if you square it. Any positive number is gonna be positive if you square it. And so this one's gonna be easy. It's always gonna be positive, regardless of the interval that you're in, right? And so here, any value to the power of 2 will be positive. So that's nice. We could deal with this x row similarly, right? If x is less than 0, it's negative, but otherwise if it's between 0 and 2, it's positive. Between 2 and 3, it's positive. If it's greater than 3, it's definitely positive. So we can do the same thing here, right? Positive, positive, positive. So the only part that really needs a little bit of work is the x minus 3 to the power of 3 row. So let's put in our test values. So we get -2 minus 3 to the power of 3. And I encourage you to use a calculator. Don't be a hero, right? You want to make sure that you get these values right because the whole answer depends on it. So if you try -2 minus 3, you can use any value that's less than 0, right? And so it doesn't matter, but I picked -2. I get -5 to the power of 3 is -125, which means that the overall result here is going to be negative in this interval. It's going to behave the same for all those values. Okay, so moving on to the next one. If we have a test value of 1, 1 minus 3, -2 to the power of 3, -2 to the power of 3 is going to be -8, so it's also negative here. Between 2 and 3, oh, hey, why didn't it, there. Between 2 and 3, I picked a test value of 2.5, so I'm going to do 2.5 minus 3 to the power of 3. Notice that an odd power is just going to preserve the sign, right? So that's a quick way that you could check in, but like I said, just kind of use your calculator if you feel the need, which I always do. I always use my calculator, even for silly things. Like I've caught myself doing 1 plus 1 in a calculator, just to make sure. So I'm not above that. So let's see here. If x is greater than 3, I'm going to use a test point of 4. 4 minus 3 makes 1. 1 to the power of 3 is going to be positive. Okay, so how do we use these? We're going to use these by figuring out the overall sign of this thing. Now let's make sure that we understand how these signs are working together. They're just being multiplied together. So an even number of negatives is going to make positive, right? Negative times a negative makes a positive. So we've got a negative times a negative, which overall is going to be a positive value. Oops. And I'll just say, since a negative times a positive times a negative equals positive. Okay. What's this saying? It's saying that when x is less than 0, this thing is going to be greater than or equal to 0, right? If it's at 0. So it's going to be positive, right? What we're looking for, right? If we go back, this feels like a while ago, right? But what we're looking for is when things are less than or equal to 0, right? So what I'll say here is that looking for intervals where this is negative, okay, where those things are negative, right, less than or equal to 0. Okay. We can do the same thing between 0 and 2, right? A positive times a negative is going to give me an overall negative value, right? Same thing here, positive times a negative, we already decided that gives me a negative. And then finally, a positive times a positive is definitely going to be positive. Okay. So it looks like starting at 0, right, and going to positive 3, that's where it's going to be negative, right? So we see that x times x minus 2 squared times x minus 3 to the power of 3 is negative or equal to 0 between x equals 0 and x equals 3. Okay. Therefore, I'm assuming you guys are okay with the therefore dots, just 3 dots in a triangle, make therefore, just shorthand. Therefore, x times x minus 2 squared times x minus 3 to the power of 3 is less than or equal to 0 on the interval closed brackets, right? Because it's including, we want to have less than or equal to 0, so we have to include those endpoints, 0 to 3 inclusive. Good. So I know it's been a while since you guys did that, but hopefully it feels a little bit familiar. And even though it seems weird to kind of break it down and only talk about the signs, it's really all we're interested in, right? So we can do something similar to what we just did, but let's use a different example. So we can have an example using quotients. So what if we have something like 2 minus x over 3 plus x is less than or equal to 4? Okay. So what we did, right, we said we established kind of our thought process here. Well, first thing I have to do is I have to move everything so that the inequality is with respect to 0. Otherwise, it makes it really hard to work with. And then we have to find all the values of x that make this equal to 0. And then we use the zeros to set up intervals, and then I forgot to list the rest, but the rest kind of follows. Once we have the intervals, we can set up a table of the individual factors, and then we can find the overall sign of this thing and figure out which intervals apply. So first thing we're going to do, right, is we're going to have to move this 4 over to the left-hand side by subtracting 4 from both sides, which leaves 0 on the right-hand side. So what we get is we get 2 minus x, and I'll kind of move it to the middle of the page here. Oops, 3 plus 3, I wish. 3 plus x. Minus 4 is less than or equal to 0. Okay. I don't know about you guys, but definitely in our section, our pre-calc section, we've worked with a lot of fractions, right? So here you're essentially subtracting a fraction from a fraction, 4 over 1, but that means you need a common denominator, right? So what I'm going to do is I'm going to multiply 4 by 3 plus x over 3 plus x, right? Using that trick of multiplying by 1, a convenient value of 1, to force that common denominator. So 2 minus x over 3 plus x minus 4, and then just to indicate that I'm doing something new here, I'm doing times 3 plus x over 3 plus x. And maybe that multiplier is confusing, so I'll ditch it. Less than or equal to 0. Okay. So what I can do here is I can expand this out, and now I've forced this common denominator, which I can use. And so I've got 2 minus x minus, and then expanding this out here, I get minus 12 plus 4x. I'm going to use brackets because otherwise I can get sloppy with this negative, right? So I need to make sure that I bring that negative inside. If you're nice and thorough, right, you could have multiplied the negative 4 inside. I like to break it up and kind of stop myself with these brackets. Over 3 plus x less than or equal to 0. Okay, I can simplify, right? If I bring this negative inside now, or if you already have, that's great. But what I can do is I can simplify this numerator. So I get 2 minus x minus 12 minus 4x over 3 plus x is less than or equal to 0. I'm going to simplify that numerator a little bit more, right? I get 2 minus 12, putting me at negative 10. Negative x minus 4x is minus 5x over 3 plus x, which we want to know, when is it less than or equal to 0? Okay. I see a common factor here. I'm going to factor that out just because I want to have it as simplified as possible. And so I get negative 5 outside times 2 plus x over 3 plus x is less than or equal to 0. One little heads up, you might be tempted to multiply both sides by 3 plus x, but because this is an inequality, right, if this thing is negative and we don't know where it's negative yet, then we would have to, then we're multiplying by negative, which means we would have to switch that sign over, right? So there's a little bit of a stop there. We can't do that. And so here, I just want to make sure that we keep track here. We can't multiply both sides by 3 plus x since we don't know if it's positive or negative. Since we don't know if it is positive or negative. if it's negative, we would have to switch the sign. I'll cut that bracket there. If it is negative, we would need to, oops, that's supposed to say switch, not switch. To switch the sign or the inequality. Okay. So we can't do that, but that's okay. We'll just keep it here where it is. So let's have a look here. If x is -2, right, there's nothing I can do to -5 to make it equal to 0. So I'm going to leave that alone. It still factors in because it's negative, right? But 2 plus x, if x is -2, then this whole thing would have to be 0. 0 divided by anything is 0. One other thing is that when x is -3, we're dividing by 0, which is illegal math, right? And so we're not allowed to do that. So what I'll say here is that when x is -2, okay, this equation is 0. Oops, combining my words, is equal to 0. When x is equal to -3, we're dividing by 0, which is illegal math, right? So it's undefined. So when x is equal to -3, we would divide by 0, which is illegal math. Oops, illegal with 3 L's. So at x equals -3, it is undefined. Okay. Which we're also going to incorporate into our intervals because something happens. Oh, sorry. Okay. I got a spinny wheel on my screen briefly. Hopefully we're still there. So we're going to incorporate where it's undefined into our interval because obviously something changes at x equals -3. And so let's set up our table, right? What we've got is we've got cutoff points at x equals -2 and x equals -3. Those seem to be kind of transition points. And so if it helps, right, I always find that it's helpful if we put a timeline on here or a little line where we put -2, oops, that's not going to work, -3 and -2 and just 0 for reference. You don't have to have it on there. In fact, maybe it's confusing. There. So we've got -2, -3, and so these intervals, right, here, x is less than -3. Here, x is between -3 and -2. And here, x is greater than -2. Right? And again, if you find it helpful to pick some points, some test points inside these intervals, right, to help us evaluate whether it's positive or negative in here, that's totally fine. But let's set up our table here. So again, we're going to have our factors. And we're going to have our intervals. So x is less than -3, x is between -3 and -2, and x is greater than -2. I'll just put up little kind of dividers there. 1, 2, 3. Go down one more. Okay. So, like we said earlier, -5, it's a factor, right? It's not going to change depending on x, but I do need to incorporate it because it's negative, right? But it's negative for all values of x. So the first one I'm going to put here is -5, which is just going to be negative all the way across. Right? So that's a nice easy one for us to do. The next factor that we have is 2 plus x, or x plus 2. And then the next factor that we have is 3 plus x. So 2 plus x, oops. And then the last factor we have is 3 plus x. I think it was 3 plus, yeah. And then overall, this whole thing, we need to figure out how it behaves together, all these signs together. And so we have -5 times 2 plus x over 3 plus x. Right? We need to combine these. So up here we're multiplying and then we're dividing. Behaves the same way as multiplication, right? So 2 negatives make a positive. So an even number of negatives make a positive overall. And so we're just going to figure out how many positives and negatives we have. So if we kind of go here, 2 plus x, if x is less than -3, right, again, it might be helpful to have little test values to use as little check-in points. So here, if I use -4, between -3 and -2, -2.5 maybe, and 0 is always nice to check in with. So what I'm going to do here is between, if x is -4, 2 plus -4 is going to make a negative number. Right? Moving across, if x is -2.5 in 2 plus x, then I'm still going to have a negative number. If x is 0 in 2 plus x, finally I've got a positive number. Same thing, starting over, but with 3 plus x. So if x is -4, just as a check-in point, right, I get a negative number. If x is -2.5, 3 plus -2.5 makes a positive, and then 3 plus 0 also makes a positive. So now, overall, here, I have a negative times a negative divided by a negative. Negative times a negative makes a positive, divided by a negative gives me an overall negative value. Same thing, you can just count the number of negatives, right? If it's even, it's positive. If it's odd, it's negative, right? Or you can convince yourself negative times a negative makes positive, divided by a positive, it's positive. We're positive. Negative times a positive makes a negative, divided by a positive makes an overall negative. Okay. So therefore, -5 times 2 plus x over 3 plus x is, I think we wanted less than or equal to, yeah, less than or equal to 0. So we want to know when it's negative again. Less than or equal to 0 on the interval. Okay, let's figure out these intervals. On the interval x is less than or equal, less than -3, it's negative. If x is greater than -2, it's also negative, but nothing in between. We want less than or equal to, and so it's equal to 0 at x equals -2, right? But it's undefined at -3, so we don't want to include that. So it's on this interval here, using our fancy set builder notation, x is in the set of real numbers such that x is less than -3 or x is greater than or equal to -2. Oops. Run out of room there. Here I'll say can't include x equals -3 since it is undefined. I said it. The whole thing is undefined there. Okay, but we can include x equals -2 because if x is -2, it's equal to 0, which we established initially. Okay. I'll finish here at x equals -3. Good. Okay, so not too bad once you figure out how to, so you have to have it factored out nicely, right? And then you need to figure out, okay, where is it positive, where is it negative individually, and then how does it combine together? Has Shaun used the Desmos with you guys? Have you heard of Desmos?
Desmos? I can't say that I have.
No? Okay. So it's a really fun tool. It's a free app. And it looks like, well, now I don't have a pointer here, but in the bottom right hand corner, there's a little green app with some squigglies on it. And so that's what it looks like. And so if you go into Desmos, it just lets you graph stuff. It's basically a free graphing calculator. But I find it's really useful to check my work, right? And so if I wanted to check my work, of course, you can't just use Desmos. You have to show your work to get the marks, right? But if I want to check my work, then I can graph what we just did. So -5, times, and then what was it? 2 plus x, 2 plus x, bracket, and then divided by 3 plus x. Okay. So here, this is what this thing looks like. Sometimes it can be tricky, right? Because we've got these asymptotes here, but it looks like if I click this, I'm able to kind of click these dots where it crosses the x and the y axis, right? So it crosses the x axis at -2, and this thing is, we wanted to know where it was negative, right? It's negative for all these values, right? Up until -2, is that what we said? Oh, -3. Whee, it's got a little gap here, which is what we found. And then here it's positive, but then after this point, it's negative. After this point, not that point. Anyways, this one was a nasty graph. What if we did the one that we worked on earlier, x times x minus 2 squared times, times x minus 3 to the power of 3. So this is what this thing looks like. Looks weird, right? But it goes, and it finds those x values where it's equal to 0, and then you can figure out which intervals it's less than or equal to 0. So it's fun to play around with, and sometimes if you're, especially if your graph is not that difficult, right, then it's easy to check your work. That first one I showed you was a little bit hard to see, but this one, right, it's negative between 0 and then it dips down here, 0 and 2. And then again, oops, it's negative between 2 and 3, and then it's positive again. Anyways, it's kind of fun to check it out. So that's Desmos. It's a free app that you can make use of. Okay. So let's talk about absolute value inequalities. So absolute value inequalities are a little bit special, right? Because the absolute value, remember, the absolute value of x is denoted by just straight vertical bars around some value or even some equation, or some expression, I should say. And it's a piecewise function, right? So it's piecewise because it's going to be equal to x if x is greater than or equal to 0. But if x is negative, it actually becomes negative x if x is less than 0, right? So if x is less than 0, negative 2, for example, then the absolute value, we can think of it as just dropping the negative, but technically what happens is it takes negative 2, which is just positive 2, right? So that's how it makes it positive. So if we're talking about inequalities here, because we've got this kind of weird situation with absolute value, there are just a couple of things that we need to remember. Okay? So, to solve an absolute value inequality, we're going to use the fact that if the absolute value of x is less than c, then what that translates to is that x is between negative c and c, right? That's if it's less than or equal to, right? But we'll establish it with just the less than, so the exclusive, and then of course we can apply it to the inclusive as well, right? But if the absolute value of x is greater than or equal to c, or greater than c, I should say, then negative c is less than x, or x is greater than c. So notice how if it's greater than or equal to, then you get these two solutions. So you have to split them up, right? And that's only if it's greater than. So here, I'll put a pink box around this because it's going to be worthwhile jotting down and just having in your notes and just being able to refer to it, right? I don't know what your guys' testing situation is with Shaun, but definitely something to have memorized if you have to memorize stuff, or definitely have handy for a test if you ever need to use it. So for absolute value inequalities. Similarly, the absolute value of x is less than or equal to c means that negative c is less than or equal to x, which is less than or equal to c. And the absolute value of x greater than or equal to c means negative c is greater than or equal to x. Wait, what happened there? Or x is greater than or equal to c. But for me, I always just like to kind of memorize as little as possible and then say, okay, well, of course it applies for less than or equal to as well, right? And greater than or equal to. But just remember this, and then the rest will follow. Okay. So let's do a little example. If we have x, the absolute value of x minus 4 is less than 2, okay? So now we've got this type of situation, right? where I've got x minus 4 inside, right? So wherever I see an x, I'm going to replace it with x minus 4. And then my c is 2 in this case, right? So I'm going to have negative 2 is less than x minus 4 is less than 2. So you're going to just take everything and transfer it over. So x minus 4 is between negative 2 and 2. Okay. Which we can solve, right? We worked with inequalities before, and so you can treat them as equal signs as long as you're not multiplying or dividing by a negative, right? And so here, if I'm adding 4 to all 3 sides, right, all 3 portions, here, 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 then I don't have to switch the signs. So here I get negative 2, and then I'm going to show plus 4 is less than x minus 4 plus 4 is less than 2 plus 4. Okay. I'm obviously showing way more work than you would have to, right? If you just wanted to go straight to positive 2 to 6 and then x in the middle, that's totally fine, I think, at least for my guys. But you do want to show that you're adding 4 to all 3 sides, or you want to make sure that that's what you're doing. So negative 2 plus 4 is 2 is less than x, which is less than 6. Okay. So the solution in interval notation, not including 2 up to 6, not including 6, right? Not equal to. What if we did, I'll call this example A, B. What if we had 2x minus 8, the absolute value of 2x minus 8 is greater than or equal to 16. So now I've got this situation, right? The absolute value of x is greater than or equal to c. In our case, x is going to be replaced by 2x minus 8, and c is going to be replaced by 16. But what we have is this type of situation, right? And so what I'm going to do is I'm just going to nab this here, copy, just so I can refer to it. Maybe shrink it down a bit here. Wink. Okay. So what we have, right, if we translate this, it becomes negative 16 is less than or equal to 2x minus 8, or, and maybe I should put it over here, or, now on to the next one. Remember, x is being replaced by 2x minus 8, and then the c is being replaced by 16. So, or 2x minus 8 is greater than or equal to 16. Okay. So, okay, now we can just go ahead and solve each of these with respect to x and see what happens. So 16, I'm isolating x, and so I'm going to add 8 to both sides here. So I get negative 8 is less than or equal to 2x. Let's see here. Yep. And then I'll divide both sides by 2. It's a positive, so I don't have to switch the sign. And so I get negative 4 is less than or equal to x. Finding some typos in the notes Shaun sent me, but it's okay. And then on this side here, 2x minus 8 is greater than or equal to 16. Again, I'm going to add 8 to both sides. 16 plus 8, I just want to make sure. 24. So I get 26 is greater than or equal to 24. And then x, if I divide both sides by 2, I get x is greater than or equal to 12. Okay. So what I'm finding is that both of these have to be true, right? So x is greater than or equal to -4, and x is greater than or equal to 12. So, sorry, I'm just seeing here, greater than or equal to 2x -8 plus then. What happened here? -c is less than or equal to x. I'm only hung up because the notes are saying something different. So I just want to make sure that we did it right. -c, -16 is less than or equal to x, less than or equal to 2x minus 8. We added 8. -8 is less than or equal to 2x. So x is greater than or equal to -4. Okay. I'm going to leave it like this. So the solution, it doesn't, you know what I did? I copied this out correctly. What is going on? I thought for a second I had turned it around. -c is less than or equal to x. Anyways, I'm going to graph it, see what it looks like. See where this thing is greater than or equal to 16. The absolute value, there's a button for it, 2x minus 8, and then end that absolute value. And where is it greater than? So notice that it has the inequalities here. One thing about using the inequality buttons, it only shows the regions. So it's not actually going to show you the graph anymore. But we want to know, where is this thing greater than or equal to 16? So looks like the region is from so up to -4, and then picking back up at 12. Or if you wanted to, where is this thing equal to y equals 16? Right? Same thing, where is it greater than this line? Well, that's everything coming down to this point and then picking up again on this point here. So up until, and that's the interval that we found. So let's see here, what did I do wrong? X is greater than, it should be less than. I divide by negative and I didn't pay attention. Anyways, the solution should be -infinity up to -4, inclusive though, union 12 up to infinity. Oops, and 12 is included. Infinity is not a number, so I'm not putting a square bracket there. This is not what I said here, but x is greater than, should be less than. Anyways, I'll have to look, but I won't waste your time doing that. I'll fix the notes. I'll kind of go through with a highlighter and see where I went wrong. I don't know, I'm not seeing it. I don't know, this one worked. This one, something happened. It's the wrong sign. Udo. I'll fix the notes and then I'll post them on Moodle. And then I'll post the video once it's done processing, because I think we're out of time here. And then we'll start lines next day. So until I hear otherwise, I'm just going to assume that I'm going to keep meeting with you guys. And we'll see you on Friday for a
Yeah, Friday.
little quick lesson on Friday.
See what we can get done.
Exactly. Crank out some lines.
Yeah.
All right. Thanks, you guys, for coming. And I'll post the Zoom link for next day, and we'll just meet in Zoom because it's a lot easier for me. And I'm sorry, but
Makes sense.
awesome.
You probably, if you have the ability to make announcements, or alternatively get Shaun to make it, put in the
Yeah.
announcements what's happening so that everyone else knows what the heck's going on.
What is going on in this course? We'll get it sorted out. But yeah, that sounds good.
Right. Ciao, ciao.
All right. Thanks, guys.